Hello everybody, welcome to this video lecture. In this lesson we're going to begin getting into geocoding in more detail and finding out what happens behind the scenes whenever you're using a geocoding service such as Google Maps or other mapping service where you're looking for an address. So just as a recap, geocoding is the ability to take an address and put a point on a map at that location. That's what geocoding is at its core. And this is very useful and very important because addresses are a very common way to communicate geographic information. Sure, yes, when we need to communicate position, latitude and longitude is fantastic. There are other coordinate systems out there that we could use. But in everyday life, it's very common for us to give addresses whenever we need to get to some place or want somebody to be able to find us or our business. Addresses are everywhere. And so we need to be able to use an address, have a computer take an address and put it on, put a point at that location on a map, whether that was for emergency service response or whether now it's just one of the things that we expect our phones to be able to do for us in order to get us to something for, after class, or one evening, or find a store or something. So it is one of the most common GIS operations that people use on a daily basis, and because it's so common, because it's on our cell phones, lots of people might not even think of this or recognize this as a GIS function. Google Maps is not as robust a GIS in many respects as some other packages, simply because of what it doesn't allow you to do. It doesn't have all of the analytical functionality. But what it does extremely well. It's one of the best at it. Geocoding is one of those things. And so we go to it and almost we just expect it to be there now. So it's one of those things that we use, but may not even recognize that we're using geographic information systems. So it does require specialized vector datasets to execute, and we're going to be referring to this specialized vector dataset as the reference layer as we go forward. And that's why we're talking about it here in vector analysis. And it's also why geocoding is not especially easy. If we're given latitude and longitude coordinates, we can plot those in a GIS, and that's comparatively easy. It's much more difficult to take something that is designed to be used by a human being, like a address, and then be able to put a point on it. And I said that this is much more complicated than just having some data table which has every possible address in it and then the latitude and longitude coordinates, and then Google Maps goes and looks up the address real quick and comes up with the latitude and longitude and puts the point. That's not what happens. So we're going to look at this in the sophisticated procedure that geocoding takes here in this video, or begin to in this video. I would also like to note about geocoding is that it is rather location specific, the procedure that's used, because different places give addresses in different ways. So when you're creating a geocoding service or you're going to use a geocoding service, you do have to realize that the way that addresses are given here in the United States is not the same way that addresses are given across the world. And that's an additional complication for using geocoding. You have to have geocoding services that understand the particular ways that addresses are given in particular locations in order to be able to place them on the map. So that's very important. I'm going to, for the purposes of this introduction here, this overview, sort of focus on US addresses, use those as my examples. But you should be aware that if you are working in some other place, you may have to use place-specific geocoding services in order to accurately place your addresses. Okay, so let's go ahead and get started here. Here we have one of our first problems that we encounter when we're trying to do geocoding here. We said that an address is really designed for a human being to use. If you're in a particular town and everybody knows Oak Street, and you say that you're at 375 Oak Street, then chances are the person will be able to get there. But this really isn't designed for a computer to be able to operate. And moreover, A major problem for geocoding is that addresses can be written in many different ways. So here's 375 Oak Street, and then maybe somebody else says, well, you know what, I'd like for this letter to go to 375 Oak Street. And they use an abbreviation for street. Or maybe somebody else says, well, you know what, I need this to go to 375, and they call this North, and they put an N here, Oak Street. Maybe there is a north and south distinction that is maybe informally made in the particular city that we're talking about. Or, somebody might just say, where do you live? Oh, I live at 375 Oak. Or I need to get to 375 Oak. To a human being, we might not even notice the difference here. If you write all of these different things on a letter that you're trying to get to somebody who lives at this address, and somebody at the post office looks at the address in order to get it to where they want to go, particularly if they are familiar with the town and residents of the town anyway, they're probably going to be able to determine exactly where that letter or that box or parcel needs to go, or where you need to go if you're asking for directions. But this is just not the way that computers operate. One of the first thing is that, computers are extremely literal. Computers are literal. There has to be some way for the computer to know, and there's not any way for the computer to know just offhand, that all of these here are supposed to refer to the same location. How is the computer supposed to know that? And that really does present one of our problems as far as what about having just that table that I was talking about that we do not have. But if we're trying to look up, an address over here, and then we have latitude and longitude over here, well, not only would we have to keep up with this table with every single possible address, but we would also have to look up or keep track in this table of every possible way that a person could write all of those addresses. And that's just through the roof complicated. I mean, the number of different variations there could be. And it might not even be possible, because think about something like Google Maps, when you've got that search bar and you just type in your address. Well, somebody may type in any one of these four, or possibly other variations, for that same location. So the computer, we've got to come up with some way for the computer to not be so sensitive about the way that the address is written. We want the computer to be able to receive this address and then get you to the right place, at least, the vast majority of the time. And then to compound the problem, sometimes people may make errors and just general mistakes about where they're supposed to go. I mean, if I do get a letter on it that says 375 Oak Road, and it's in a particular city, or a particular town that's known, well, I bet that this is just a mistake. Oh, this person said Oak Road, but they really meant Oak Street. I bet I can get the letter there anyway. But the computer, again, even if it could figure out all the different possible variations of this street, well, what if somebody types in road? What if somebody gives it road? Can the computer recognize that probably is just a mistake on the person's part, like the postmaster would, or the letter carrier would? Probably not. So basically, what we're going to be doing is, the first process we go through is called address standardization, and we'll look at that in more detail in a moment. But basically, you're going to find that addresses can be chopped up into several different parts. And so we're going to want the computer to chop up an address that it's given to try to geocode into several different parts, and then compare all of those parts to different locations or different attribute information in that reference layer. And then we are going to rate the quality of the match. How how high quality is the match? How sure is the computer that it was going to be able to place that dot or that flag in the right place? And so basically the computer is going to generate a score. Sometimes the score is generated from 0 to 100, 100 being a perfect match, and then anything less than, well, really about 60 is a poor match or no match or unable to be found. So, then we'll be able to come in here and we'll say, well, I'd like a high score. Let me find all of the addresses that the computer was able to match with a quality score of greater than 80. Maybe those are real high quality matches that we're really sure about. And then maybe we have another one, another sort of bin for all of the matches between about 60 and 79. So these are pretty good matches. They're not great. They're pretty good. Maybe we want to review them. Maybe for some purposes we would accept them as matches. Maybe for other purposes we wouldn't accept them for matches. And then maybe anything less than a 60 score, we're going to say the computer wasn't sufficiently able to find a match in our reference layer for that. So that's basically what we're going to be able to do. We're going to do here. So let's take a look at this process of address standardization in more detail. So here is address standardization, and what this means is that the computer is going to receive some input. So here's our input right here. If you're thinking about Google Maps here, this is going to be the address that somebody types into that bar. And then as soon as you hit enter, the computer is going to go through this address standardization process to try to figure out what it is that the person who typed this in meant by this address. And to do that, it's going to sort it into a bunch of different categories. These are the different ways that we can chop up that address. An address, here again, this is United States sort of specific here. Addresses here in the United States can very frequently be chopped up into these component parts. And so we have all of these different component parts here. So what do these mean? Well, here we have a prefix direction. What is a prefix direction? This is the direction indicator that comes before the street name. So, if we were at North, I gave you the example of maybe there is a North Oak Road or North Oak Street. This right here, maybe there's also South Oak Road. So this N would be a prefix direction. Oh, we've got a direction going on with our prefix. Okay, so what is prefix type? Well, the prefix type is going to indicate something about the type of the road that comes before the name of the street. Okay, so this is anything that comes prefix. This is before the street's name. Anything that might give us some kind of indication of the type of the road. Now, notice if we had Highway 280. 280, that's actually going to be the name of the street in this case. But then here, highway, this gives us an example, or this gives us an indication of the type of street that it is, or type of road that it is. So in that case, highway there would be prefix type. If you've got an interstate, Interstate 85 or something like that. Interstate may be your prefix type, or interstate would be your prefix type, and then 85 in that case would be the name there. The number, that's pretty self-explanatory. That's your house number or building number. That's where that goes into. Okay, then the street name, whatever it is the name of the street is, like Oak in this case. Then street type, this is everything that comes after that name of the road, or name of the street. So if we have Oak Road here, well, what is this? This is road that would go into street type. There's avenue, boulevard, street, circle, court. All of those are different types of streets, and that's what goes in here. The last thing here, or last thing before the zip code, is the suffix direction, and this would be something that would come after this name. So, we can have North Oak Street over here, but what if we had something like Palm street, east. Okay, so east would be the suffix direction. This isn't East Palm Street, this is Palm Street East, so we have a suffix direction in that case. And here we have the zip code as well. That one's pretty self-explanatory. I don't have the zip codes over here in the example, but if you have a zip code given as well, well, that's obviously a big help in locating a position. And so we've got a column over here for zip code as well. So this is how the computer is going to try to chop the address into a bunch of different all these different parts in order to try to ultimately match it with the reference layer. So in this case, with 375 Oak Road, excuse me, here we go and start entering this information. So 375 is the house number that's on a street named Oak, and what kind of street type is it? It is a road. So there we go. This is how the computer would chop up 375 Oak Road in order to go when it goes through this address standardization procedure. Let's take a look at a few more. Let me clear my marker here, and then let's take a look at these. Maybe you can look at how they're going to be broken up as well. 27 Middle Street North, 971 Highway 85 East, and then 429 East Alaric Street. So here is, when those are passed to the computer, here is how it would go through the address standardization procedure. 27 Middle Street North, there we have a suffix direction for north, so we put that over there. 971, that is the number of a building, and then here we have highway, a prefix type. What highway is it? The name of the street in this case is 85. And then 429 East St. Alaric's Street. This one's a little bit tricky for a computer, perhaps, because we have the ST, which here is intended to represent Saint, and then we have ST at the end again, but there is supposed to represent street. So here we have a prefix direction, which is east. This house number is 429. What is the street name? It is St. Alaric Street. And then what's kind of, or it is St. Alaric, that's the name. And then what is the street type? Well, it's a street. So here we go. That is how we chop up all of these into a bunch of different categories for the computer to try to be able to match these. So I would like for you to take note of a couple of other things here. First of all, note that in addition to chopping this up like this, that all of the text was converted to uppercase. And that's important because, as we said, computers can be extremely literal, and sometimes they don't recognize uppercase and lowercase letters being the same, depending on what kind of database matching you're using and so forth. And so here we're just going to take care of this by saying we're going to convert every letter into an uppercase letter, and that way we don't end up with confusion about whether or not capital H then lowercase WY is the same thing as a highway, and it's the same thing if it were all capital letters, or anything like that, or any kind of capitalization within a street's name or anything like that. We're just going to convert everything to uppercase so we don't have to worry about case matching, because that could throw us off. Probably if something is uppercase or lowercase might not actually be indicative of a different location. We don't in the United States differentiate between locations based on whether or not particular words are capitalized. So in addition to that, we've tried to standardize abbreviations. So if a computer goes in and finds north like it does over here, well, we're going to just have N here. East, we're going to end up with east over here. Street, ST, road over here becomes RD. So we're trying to standardize that. Different algorithms that the computer has when it's chopping up this address in order to sort of standardize, well, street, that's ST, road, that's RD, and then these are the standardized abbreviations that are going to be used in the reference layer in order to try to match them. So again, we don't want this problem with this, ROAD, is that the same thing as RD? We want to simplify here. So the computer has algorithms to do that when it's going through this address standardization process. Okay, once the computer has gone through address standardization, it is time to try to match it to the information in the reference layer, and we will talk about what information the reference layer needs to have that specialized vector dataset in the next video.